Preparing your critical business applications for disaster recovery is key for business continuity. In this demo, I will showcase how Veritas Alta Enterprise Resiliency provides disaster recovery for Oracle's single instance database in the cloud. Let's look at what this deployment looks like in AWS Cloud. There is a production site in North Virginia region and a disaster recovery site in the Oregon region. In each of the regions, there is a VPC that has 3 different availability zones. At the production site, there are 2 EC2 instances with EBS volumes created within different availability zones. Veritas Alta Enterprise Resiliency is installed in these 2 instances to form a cluster. A coordination point server is deployed on an EC2 instance in a different availability zone to maintain data integrity within the cluster for split-brain scenarios. The centralized management console, also known as VIAM, is deployed on another EC2 instance to manage the storage and high availability of the resources within the cluster. At the disaster recovery site, there is a similar configuration where there are 2 instances with additional EBS volumes in different availability zones and a coordination point server in another availability zone. There is also a DNS server to translate the names to their associated IP addresses. From DNS, there are entries for each of the EC2 instances in this deployment and entries that allows for the high availability and disaster recovery of Oracle. Also configured is VPC peering to allow for network connection and routing between the 2 VPCs. Now let's look into how Veritas Alta Enterprise Resiliency makes Oracle running in this environment highly available and resilient to disaster using VIAM, the centralized management console. Under Data Center in the Server tab, we can see that the 4 EC2 instances have been registered. 2 instances for the production cluster in the East region and 2 instances form the disaster recovery site in the West region. Expanding the system resources in the production cluster, a disk group was created and enabled for flexible storage sharing. This disk group is comprised of the EBS volumes in each of the EC2 instances in the East region. From the disk group, volumes and cluster file systems are created and are accessible by both nodes in the production cluster. Likewise, the disaster recovery site in the West region has a disk group comprised of the EBS volumes in each of the EC2 instances. From the disk groups, volumes and cluster file systems are created and accessible by both nodes. After the cluster file systems are mounted in each of the nodes, Oracle's single instance is installed in each of the nodes in both regions. Veritas Alta Enterprise Resiliency Volume Replicator can replicate data to another site synchronously or asynchronously. In this environment, data is replicated asynchronously. Core to this mechanism include the replicated volume group, which is a group of volumes within a disk group that would need to be replicated to the other volume group in the disaster recovery site, and the storage replicator log, where writes to the data volumes are first queued before they are replicated to the other site. To place Oracle under control of Veritas Alta Enterprise Resiliency for high availability and disaster recovery, service groups are created in the Availability tab to define how the resources within the production site is to fail over to the disaster recovery site. The service group include the data service group, which contains the volume resources for Oracle. They are active and mounted on both nodes as indicated by the blue boxes underneath each node name. The parallel mounts allows for fast failover to passive node when active node fails. The Oracle service group is in failover mode such that the main Oracle resources are only active on one of the nodes indicated by the blue boxes and passive on the other node as indicated by the gray boxes. The Veritas Alta Enterprise Resiliency has specialized agents for Oracle, storage, network interfaces, and cloud agents to monitor and manage the resources within the service groups. The cluster service group includes a wide area connector process, which is a failover application resource that ensures communication between the cluster. It receives and transmits information about the status of the cluster, service groups, and systems. The log owner service group manages the resources that writes to the storage replicator log on the production site. Its main role is to maintain the order of writes by designating one node in the cluster as the log owner. This service group is key to the volume replicator. And finally, the volume replicator service group, which contains the resources that are responsible for the replication to disaster recovery site. Looking at the cluster to disaster recovery site, there are similar service groups. Notice that the data in Oracle service groups are passive in this site. In case of a region failure, the disaster recovery site deployed in another region can be brought up. In the Solutions section, a recovery plan can be defined to bring up the disaster recovery site, which would involve placing online the resources in both the Data Service Group and the Oracle Service Group. A plan can also be defined to do a failover from the production site to the disaster recovery site to rehearse a failover or conduct a planned maintenance on production site. This entails offlining the Oracle and Data Service Groups in the production site and placing online the Data Service Groups and then the Oracle Service Groups on the disaster recovery site. Now let's simulate an actual two-node failure on the production site in the East region. First, let's check the current state of the environment. Oracle and data resources are running on the production site in the East region and passive on the West region. From the replicated volume group in the Server tab, we see that the volumes are being replicated from the production site in the East region to the disaster recovery site in the West region. Testing the connection from the SQL developer, Oracle is up and running. Note that Veritas Alta Enterprise Resiliency has cloud agents to manage the AWS IP addressing of the Oracle DNS entry in the DNS server. Currently, the DNS entry for Oracle is currently mapped to the virtual IP of the node running Oracle services in the production site, which is AJ Zora 5. After the disaster recovery site takes over, the cloud agents will reassign the DNS entry to the virtual IP of the node running Oracle services in the disaster recovery site. Now let's shut down the nodes in the East region from the AWS console to simulate a failure. From VIAM, we can observe that Veritas Alta Enterprise Resiliency detected and alerted that both servers are down. Testing the Oracle connection using Oracle SQL Server, the database is visibly down. At this point, we can go to the Solutions section in the Availability tab and execute the plan which will automate the online of data and Oracle service groups in the disaster recovery site in the East region. Viewing the service group cluster status of the disaster recovery site in the West region, you can observe that the Data Service Group and Oracle Service Group is coming up. Now that Oracle and data services are running on AJ Zora 7 in the disaster recovery site, we can refresh DNS from the AWS console and see that the DNS entry for Oracle has been updated to the virtual IP of node AJ Zora 7. From the Oracle SQL developer, we are now able to connect to the Oracle database and run a simple query to confirm that Oracle is indeed running and has been mounted. As shown from this demo, Veritas Alta Enterprise Resiliency provides a disaster recovery solution to enable business continuity of your Oracle environment in the cloud. Thank you for watching.